All right, a couple new kind of terms and things to remember that we're going to start off with here. First of all, a perpendicular bisector of a segment. It does exactly what it says. It bisects the segment and it's perpendicular to it. In other words, it's a line, a ray, or a segment that's going to be perpendicular to the segment, and then it's going to go to the midpoint of that segment. So you can see right here, this is an example of a perpendicular bisector, line FC. Line FC is perpendicular to segment AB, and it goes to the midpoint of segment AB. I can tell that C is the midpoint of segment AB because AC is congruent to BC. So this is a perpendicular bisector of this segment. Now, Theorem 4-5 says that if a point lies on the perpendicular bisector of a segment, then the point is equidistant from the endpoints of that segment. Equidistant means the same distance away from. So what does this mean about our picture? What this means is if I look at point F, which is on the perpendicular bisector, if I go from F to B and I go from F to A, those two distances will be the same. In other words, segment FB would be congruent to segment FA. If I picked another point, let's call it point G right here. Point G is also on the perpendicular bisector of segment AB. Now, if I went from G to B, or if I went from G to A, those two distances will be the same. So segment GB would be congruent to segment GA. And it would be true any other point that I picked on that perpendicular bisector. If I picked a point down here, called it X, then from X to B would be the same distance as from X to A. And that's what Theorem 4-5 says. Theorem 4-6 is basically the converse of Theorem 4-5. If a point is equidistant from the endpoints of a segment, then it does lie on the perpendicular bisector of that segment. So in other words, if I look down here at this diagram, I notice that J is the same distance away from K as it is from H. What that means is if I drew the perpendicular bisector of segment KH, if I found where the midpoint is, right, so the midpoint looks like it would be about right here, I call it M, say that it's the midpoint, it divides KH into two congruent parts. And then if I drew a line perpendicular to segment KH that goes through that point M, it's also going to go through point J, right? If that was the perpendicular bisector of segment KH, it's going to go right through J because J is equidistant from K and H. Now, the second term that you need to know is talking about the distance from a point to a line, right? So in other words, if I could just kind of sketch out what I'm talking about here, let's say I have a line right here, and then I have some point out here. Call it point P. And this is line L, let's say. Well, how far away is point P to line L? If I were going to measure that distance, would I go from point P over to here on this place on the line? Is that how I would measure the distance? Or would I go from point P down to here, right? Would either of those things represent the distance? No. The way we would measure the distance from point P to line L is we would go, what I would say is directly over to line L. I would go the shortest way possible to line L, which happens to end up being a segment that is perpendicular to the line. Happens to be this segment right here that's perpendicular to line L. That would be the distance from point P to line L. Now that's important because of these two theorems that we're going to look at right here. If a point lies on the bisector of an angle, then the point is equidistant from the sides of the angle. So you look in this picture here, line AF is bisecting angle EAG, right? You can see that angle EAF is congruent to angle GAF. So line AF is the bisector of angle EAG. That means that if I pick some point like J that's on that angle bisector, J is the same distance away from this side of the angle as it is from this side, which in this picture would mean that JH would be the same length as JI, or that those two segments would be congruent. if I picked another segment right here and I went straight over to that side and straight over to this side in a way that makes 90-degree angles here, these two segments would be congruent. Theorem 4-8 is the converse of Theorem 4-7. If a point is equidistant from the sides of an angle, then the point lies on the bisector of the angle. So in this picture right here, you'll notice that if Q is the same distance away from P as it is from T, and that these are right angles, that means that if I connect R to Q with a line or a ray or a segment, then this angle right here, this angle right here will be congruent to that angle, because this must be the bisector of this angle ORS.